So we're going to dive into sequences a little bit more deeply in 8.2. And we touched on the fact that the limit of a sequence in the overview in 8.1 is really similar to limits at infinity. And when you look at limits at infinity, what you're really doing is you're exploring the end behavior of a sequence. So for end behavior, you're going to look at a limit at infinity of any function. And it's going to be the same for sequences, except instead of x being any real number, you're going to look at integers. So it's exactly the same for sequences, but the only thing different now is that n is an integer. So this is interesting to study. This is an interesting, hold on one second. Sorry about that. So anyway, this is an interesting topic for, any kind of pharmaceuticals, drugs, money, life of appliance and manufacturing, satellite life, anything like that where we look at end behavior. But the basic idea behind the limit of a sequence is you're going to use, grab another color, the general idea is that you're going to use the explicit formula, right? There were two ways to define a sequence. You can define it through a recurrence and explicit formula. We're going to look at the explicit formula for the sequence, and we're going to take the limit of that explicit formula. So we're going to, let that explicit formula equal f of x. Then we're going to evaluate it. Evaluate the limit at infinity. And because all the terms of the sequence are integers, they're going to lie on the graph of f of x as well as the real point. So, if you graph a sequence, it's going to be a bunch of points, right? And say that's your sequence. Well, that may be the graph of some sequence. Okay? Well, the graph of the function, that's the graph of f of x. Oh, I'll have to pause here again. I'm sorry. So the general idea is that we're going to use the explicit formula for the sequence and let that be f of x. You're going to evaluate the limit as x goes to infinity of the function, right? So if the graph of f of x approaches a limit, right, then the sequence is also going to approach a limit. So if that approaches a limit, L, this will also approach a limit L, because all those points in the sequence are on the function. So that's why basically we're going to use the explicit formula and take the limit, and then we'll get the limit of the sequence. So the bottom line is, scroll here, grab another pen, that the limit as x approaches infinity of the explicit formula, if that equals L, then the limit as n approaches infinity of that sequence also equals L. Okay? So that's the general idea behind limits of sequences and obtaining them from the limits of the functions. I think I'm going to stop there and call that the first overview. Then we'll get into some terminology for sequence in the second one.